Okay, so here's our standard pan and our standard lid. We're going to go over how you would prep your sample and put it in here. The sample prep is largely dependent on the type of sample you use. Obviously, you're going to have to weigh your sample at some point. The method you use to weigh it is going to determine the accuracy of your data. If you're not real concerned about the accuracy of the endothermic or exothermic reaction, you just want to get the temperatures, then you could use just a inexpensive scale. If you want extreme accuracy, you're going to need a precision microbalance. So let's assume you're using a precision microbalance. What you're going to do is you're going to place your pan and your lid on the balance, and you're going to tar it out. Then you're going to remove the pan, place your sample in it, put the lid on, and you're going to just take the back of your tweezers is the best way to do this, and push down a little bit. And then you're going to take and transfer this into this press. This is our universal sample press with the crimping dies. We also sell a standard press with crimping dies. The universal press also allows you to put the hermetic dies in it, or you can buy it with just the hermetic dies. You just pull down on this lever, you just push lightly, you don't have to push hard, and you'll see now that the pan has been crimped on the edges. And we now put this back in the microbalance and weigh the sample and record that for your experiment that you're going to run. The hermetic pan is going to be similar to this in that you're going to use the hermetic pan and the hermetic lid, and then you'll switch the dies out to the hermetic dies. There is a preforming tool to preform it, and what it'll do is it'll go and curl the edges down, and then when you come down with it, it will hermetically seal using a cold weld the top edge here over along the rim of that pan, and you'll get your hermetic seal. As far as weighing it, things like that, they're very similar, and preparation of the sample is very similar. A couple of things to note about preparation of the sample: if you're using something thin like a film or similar, simple hole punch with a diameter that is smaller than the ID of the pan works very well. You just punch out your sample and place it in there. Otherwise, you'd use, if it's a hard plastic or something, you'd use like a side cutters and cut a piece off, or a razor blade. Powders and liquids you'd place in there. The powders with a spatula, small spatula. The liquids, you'd probably use a small pipette. One of the common questions we get is how sample placement affects results. And with the DSC here, you can see on the heat flux plate, there's a nice pad here that's raised that indicates where you sent them. So we're going to take our sample here that's crimped with the pan, and then the reference that's also got a lid crimped with the pan, and we're going to set them on the appropriate sides here. We're going to center them as much as possible. You can see they can move, and centering them goes and gives the best surface area between the sample and the heat flux plate itself. Once that's done, we're going to take our inner lid. You can see this is actually a fairly thick silver piece, which goes and gives very good heat distribution between the host cell and keeps everything very constant. We don't want to drop that in because dropping it can go and move the pans around. They don't move easily, but they can move. Next thing we're going to do is put the inner stainless draft shield on, and finally follow it up with the top. That prevents any movement of gases around inside that are going to cause unwanted drafts. Then the other thing that is critical here is the purge. We recommend purge rates of 3 to 5 cc for the purge if you are purging. If you go in excess of 20 cc or more, you can actually cause enough current inside the cell to move the pans around. Those are lightweight pans, and they do move if you increase your purge rate too fast.